Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. So for this lesson of definite integration, we'll have double integration square root 1 minus r squared over square root 1 plus r squared d sigma, and the boundary for r is from 0 to 1. R is bigger or equal to 0, smaller or equal to 1, while theta is bigger or equal to 0 and smaller or equal to pi over 2. So first of all, why don't we just draw the bound? Since we have the boundary, so the area boundary will be pretty easy to get. So what is the area bounded? So over here, so as you can see for this part over here, so the radius is from 0 to 1. So for this part, the unit will be from 0 to 1, while for the theta, it will be from 0 to pi over 2, which shows that it is only in the first quadrant, like this. And the radius over here, 1 and 1. Okay? So the area bounded is basically just this part. Okay. Now over here we have already known the area bounded. We already know the boundary. Now why don't we get into it already? So are we going to integrate with the r first, or are we supposed to integrate with theta first? Well, you'll see. Well, for this part, so you can put them together if you like to. Okay, so what is d sigma? So over here we're using polar coordinates for a quarter circle and all, right? So it'll be r d theta. So that shows that for now we can already integrate what theta is equal to. On the other hand, for r, we will not be so sure. And if you see closely over here for this part, even if you put this inside or whatsoever, you'll not be able to integrate it, right? So for this part, we're going to use substitution, while for the theta, we can just straight up integrate it. Okay, so for this part, what are we supposed to do with our... So we only know that there's a pi over 2 over here. So we are going to use substitution for this part, and we are going to let this whole part square root 1 minus r squared over 1 plus r squared be equals to t. And then this t, it was so over here, in order to find t for later on, because of the dt over, like later on we also have to find what dr and r is. So for this is equals to t. Thus 1 minus r squared over 1 plus r squared is equal to t squared. Meaning that 1 minus r squared is equal to t squared plus t squared r squared. And showing that for t squared r squared, so this part we can take out the t squared, where at your end, well, you can put the t squared over here and put the r squared for this part, and you'll get, so you know what t is equal to, so you also have to know what r is equal to for later on. So thus you have 1 minus t squared equals to r squared plus t squared r squared, and you can take out the r squared over here, which you're going to get r squared 1 plus t squared which you are going to get. So r is basically equals to 1 minus t square, or r square is equals to 1 minus t square over 1 plus t square. Thus, so now we can differentiate for both sides to get our dr, what dr is equals to. So here we're going to have 2r dr, the differentiation for this part. Well, for this part, on the other hand, when we differentiate our numerator, we're going to have we're going to have like this, right? We're going to have negative 2t, and then we also have the dt and all. So over here, for this part, we can use chain rule, which we have one part which is 1 plus t square and t square, and then bracket square, and then we'll have another 2 from the t square, so you're going to end up with a negative 4 dt for the numerator part. Okay, so now that you have gotten for this part, so what is the boundary for t? So t's boundary would be, so when r approaches to 0, whole t would, if you sub it in for this part, if r is equal to 0, t will be square 1 over 1, which means that t will be 1. And when r is approaching to 1, it will become 0 over 2, which will end up with a 0. So the boundary for t will be from 1 to 0. Well, for this part, what we are going to have is, so as you can see, we have this RDR, right? So the RDR, you can use it over here, but since over here doesn't have a 2 since this has a 2 compared to this part which doesn't have a 2, so both sides of this part will need to divide by 2, so the numerator, you get negative 2t. But wait, over here we already have a t for this part which we substitute inside, so negative 2t squared over 1 plus t square dt. Now that we have gotten this part, we can move this part out, and if you realize, you can use a negative to change the boundary from 1 to 0 to 0 to 1. So here you're going to have pi from 0 to 1 t squared dt over 1 plus t square. But now we've gotten to this part. What are we going to do next? So over here, for this part, we know that there's a pi in front. And since we cannot continue like this, so why don't we use the substitution again? So this time we're going to let t be equals to tangent gamma over here. So as you can see, for this part, that will show that gamma will be equals to inverse tangent t. Thus, the boundary will be, so when t is equals to 0, so the gamma will be equals to, so it will be equals to 0. Then what about why is inverse tangent 1? Well, it is pi over 4. Thus, when we substitute this inside, what we are going to get is tangent square gamma. But wait, another part is you have to differentiate on both sides, which you are going to get. So here dt. Well, for this part, what is the differentiation of tangent? It will be secant square. Basically 1 over cosine square. So secant square gamma d gamma. Okay, so now this part you also have 1. And then for the denominator, we will have 1 plus tangent square. So what is 1 plus tangent square? Well, 1 plus tangent square through a formula, it is, secant square. But since we have a bracket square outside, so it's going to be secant to the power of 4. And now that we have gotten this part, what we're going to have for this is, this part you can simplify and you get a square, and then for this part what you're going to have is, so tangent is basically sine square over cosine square, right? While secant is basically 1 over cosine, so since here got square, so here you're going to have square gamma, d gamma. So apparently these two parts you can straight up simplify it, and then you'll be left with this. Well, you can straight away integrate, and well, for this part you integrate it, but before that you have to use a double angle formula, 0 to pi over 2, 1 plus cosine 2 gamma. Okay, so over here what you're going to have for this part is that, so now that you have gotten for this part, what you're going to do, you can integrate for the 1 already, which you're going to get pi over 2. Wait. Whoops. Okay, so now that we have gotten this part, we're going to minus pi over 2, and then instead it will become pi over 4, because you need another 2 for the d gamma over here, which you need a 2, and then here you can integrate it again. Then after that you're going to get, so cosine, you get sine 2 gamma from 0 to pi over 4. Now that you've gotten this, you can substitute for both of them, right? So for this part, you substitute 0, you can ignore it. Well, for this part, when you substitute the pi over 4, here you have pi over 2 times pi over 4. And then you're going to minus pi over 4. So this part, when you sub the gamma into the boundary over here, you're going to get sine pi over 2. And what is sine pi over 2? 1. Okay. Then what about sine 0? Well, sine 0 is still 0. So thus the result that we will get will be this will be the result, and if you want to write it in another way, then like this, pi minus 2 pi times pi over 8. So over here for this example, we mainly just use substitution twice. We also use the double angle formula for sine, and we integrated. Okay, so that is pretty much it, and that'll be all for this lesson. Last but not least, thank you for your watching.